Employment and job creation are often looked at as key factors in analyzing the economic strength of a nation, particularly in the US. One factor not discussed often enough is absenteeism, which can be defined in a broad sense as the habitual absence of an employee from their place of work. Absenteeism's effect on the economy has been considered prior in a number of studies. One such study by Grinza and Ricks for the IZA Institute of Labor Economics found that for a 1% increase in employee absenteeism, productivity declined 0.24% on average. A similar study in Japan found that of 6,700 employees citing neck or back pain as physical causes of absenteeism, or depression, anxiety, and emotional disorders as psychological causes of absenteeism, high wage and performance loss were observed. From an economic standpoint, the annual cost of depressive symptoms related to absenteeism in the US is approximately $44 billion, with up to 9.7 to 14 hours per week of lost productivity among chronic sufferers. The objective of this project is to use census data to determine what factors most predict absences of workers in New York State. We can then prescribe the best approaches employees can take to reduce absenteeism and the associated wage loss, in addition to how employers and public institutions can best serve the population to reduce the need for employees to be absent from work, subsequently reducing the loss in productivity. The problem statement is twofold. The primary aspect of the problem statement is what demographic, employer, and socioeconomic factors selected from those collected from individuals in New York State for the US Census result in employees being absent from work. As a secondary measure, the problem statement will also consider, can the trends in New York data be extended to other populations to create a more universal model for predicting the likelihood an employee will be absent. The primary dataset used for this project is the US Census data filtered for individuals in New York State. Some of the categorical variables selected were educational attainment and industry. Binary variables selected included sex, maternity status, health insurance coverage, and disability, and continuous numeric variables used for model building include age, number of persons in the household, number of children, and wages or salary in the last 12 months. The second data set used to address the second part of the problem statement was titled Absenteeism at Work and was composed of records over a 3-year period from a large courier company in Brazil. This dataset contained demographic and socioeconomic factors, as well as a response detailing whether or not the employee had been repeatedly absent during the time period of analysis. Feature engineering was required to filter, clean, and transform our initial set of factors. It was not uncommon for some factors to have missing values, which could be attributed to the person not reporting the status for that factor, or it not being applicable to the person. Factors with missing values accounting for a small portion of their data, about 2%, were dropped. Factors with a large percent of missing values were dropped entirely from the analysis, such as household presence and age of old children, which had 22% of values labeled as missing. In addition to handling missing values, we transformed some factors with respect to their categories and values. One such variable was education level, which included categories for every grade level and type of degree, resulting in 24 categories. To reduce the number of categories, we split this factor into 3 buckets: bachelor's degree, graduate degree, and other. A similar process was used to create categories for the factor work hours per week, since the values were heavily imbalanced as shown in the graph on the right. This bucket was split into full-time and part-time workers. We also considered transforming the response variable. The response variable was imbalanced, as in the original dataset, persons that were absent only accounted for 2% of the data. Oversampling was applied to balance the data and include more samples that are labeled as absent. One variable available in the census data is a person's weighting, which is how much does this person represent the population. Our oversampling method was to apply this weighting to people who were labeled as absent. Using a function of the weighting raised the representation of absence to approximately 10% of the data. After preprocessing and feature engineering, the correlation was measured for the selected variables. As shown in the correlation matrix, none of the predictor variables show a particularly strong correlation with the response absent at first glance. Only a few variables appear to be correlated with each other. For example, the variables number of children, NOC, and number in household, NP, are correlated with the category household presence and age of children, HUP-AOC. These variables could be combined or dropped in future analysis. Logistic regression was used with and without the weights, and the top table shows the initial results for the top 10 variables with unweighted absence. The top 3 variables are whether a person has given birth within the last 12 months, whether the person has a disability, or whether the person has insurance through their employer. The result for absence with the weights applied are shown in the bottom table. The top 10 variables with weighted absence are similar, 8 of the 10 are the same, with oversampling, and the coefficient values are greater, since the categories for absent samples have greater representation. Our initial analysis used logistic regression to predict absenteeism. The immediate next step is to evaluate the performance of the logistic regression models. We also plan on fine-tuning our variable selection and feature engineering methods based on these initial results. Another option is using regularization methods such as lasso-CV. Other classification methods such as SVM and KNN could also be used to predict absenteeism and compare the effect of each factor. Because the absence response variable is imbalanced, it will be essential to compare confusion matrix outputs for each model. We also plan on comparing absenteeism across different industries, as we expect the features will be ranked differently depending on the type of work. Finally, we plan to compare the models from the census and Brazilian datasets. To compare the models, we'll compare the rankings of variable importance to show how similar or different the predictors of absenteeism are in New York and the Brazilian company in an effort to start to build a more universal model.